All right, this is the last part of the first lesson for chapter 8. This kind of takes a lot to explain how to do one of these lattice energy problems, so I wanted to do a separate video for this. So before we can start, the lattice energy is something that you need to understand what that is. The definition is that it's the change in energy that takes place when separated gas ions. So first thing I want you to notice is there are two things that have to happen in order for it to be a lattice energy reaction. It's got to be a gas. Both of them have to be in the gas form, and they have to be charged. And then when you take those two gases with charges and pack them together to make a solid, we're calculating that amount of energy. That's called the lattice energy of the solid. It's going to be exothermic because anytime you form a bond, it's going to give off the energy because it's going to be more stable as the compound, and so it has to release some of the energy that it had as separate ions. So it's going to give off some energy, which is exothermic. And what we're going to do is use that because the lattice energy plus all of the other steps that it takes to form that reaction are going to give us the heat of formation. So you could be given all the different steps and asked to add them up to get the heat of formation, or you could be given the heat of formation and several of the steps, all but one of them, and then asked for one of those steps. And so what you want to do is to focus on two different reactions, the delta H reaction and the lattice energy reaction. And then what you're going to do is try to get it to go from the delta H reaction to the lattice energy. I'll show you what I mean in just a minute. First, just take a look at these steps and notice that some of them are positive and some of them are negative. The negative ones are ones that are forming bonds. So in that first one, the delta H, you're taking two different things. It's a synthesis reaction to form a compound. In the second one, sublimation is solid to gas. You have to separate the intermolecular forces to get them to go from a solid to a gas. So it's kind of like you're breaking bonds, you're separating the particles. So that's why it's positive. In the next one, ionization energy is pulling off an electron. So again, it's kind of like you're breaking a bond. So notice that the energy is positive. For the next one, we're talking about the bond energy of taking or breaking the F2 bond to separate the F ion or the F particles. So instead of having a compound F2, we're separating it into one fluorine. And you may ask yourself, well, how can you have half of it? And just remember that those coefficients are actually ratios. So it's okay if you have a 1/2 in there because it doesn't mean it's not an amount of something, it's a ratio. And the definition for the delta H reaction is that you have to have 1 as the coefficient on the right side of the arrow. So that lithium fluoride has to be 1 mole. That's the definition of the delta H, is that you're forming 1 mole. So in order for that to be balanced, to have it a 1 there, you have to have a 1/2 for the fluorine. So that's okay to have that there. And then the electron affinity, you're sticking an electron on, so it's kind of like you're forming a bond, which is why it's negative. And then the last one is the lattice energy, where again, you're forming that solid from the gas ions. And so that one's negative as well. And notice that we're going to see Coulomb's law again coming back over here. So Coulomb's law is not going to go away. Go ahead and get used to those two factors, the charged ions and the distance between the atoms. And let me just do an example for you. This is actually number 58 in your textbook. So this is the delta H of the reaction. So notice that you have the compound. For delta H, I didn't mention that over here. Delta H right here, it says it's two things in their neutral, natural state coming together to make 1 mole of compound. So what I mean by that is magnesium is a solid, it's a metal. And so in its natural state, if it's just plain old magnesium, it's neutral, it's going to be a solid. For fluorine, in its natural state, first of all, it's diatomic. It's one of the Hofbrinkel elements. And second of all, it's a gas. Just like oxygen is a gas and nitrogen, most of them, the diatomic ones are going to be a gas. The only exception there is bromine, which is a liquid. And then they're going to come together to make a solid. Don't forget to cross your charges. And it's just the solid compound. So this red equation is the delta H equation. The next thing you want to do is to write out the lattice energy equation. So remember, lattice energy, you're still going to form 1 mole of the solid compound. So the product will be the same for delta H and for lattice energy. But on the left, instead of having the things in their normal states that are neutral, they're going to be gases and they need to be charged. So magnesium has a +2 charge. We can put a gas. And fluorine is negative, and it's a gas as well. However, in order to balance this reaction, we need a coefficient of 2 for the fluorine right there. Now that we have lattice energy, we're ready to write out the other steps. So what you want to do, just like it says over here, you want to get it to go from the delta H to the lattice energy. So starting with the red equation, we need to turn those reactants, the red ones, into the blue ones. So I'm going to start with that solid. And what I need to do is to turn it into a gas, and I need to make it charged. Doesn't even matter what order you do it in. I'm just going to turn it into a gas first. That is called sublimation. Then what we're going to do is take that gas and we're going to make it charged. So we're going to take the neutral gas magnesium and we're going to pull off an electron. So now instead of the electron being stuck to it, now we have an electron separated from it. And in the process, it makes it +1. That is called the first ionization energy because you're taking off the first electron. All right, then we got to take it off another one because you can't take them off at the same time. You can put them on at the same time, but you can't take them off at the same time. So now we need to do the second electron because we need it to be +2. So notice that I'm going to start with Mg plus because that's what it was right there. And I'm going to take off a second electron to make it 2+. And that is the second ionization energy. And so now we've taken Mg solid, which was in the red equation, we've turned it all the way into Mg2+ as a gas, which is now in the green equation. So we're done with magnesium, now we need to do fluorine. So starting with the red equation, we're starting with fluorine as a bond, and it's a gas, which is good, we want it to be a gas. And what we need to do two things to this fluorine to get it to be like the blue fluorine. We need to separate the bond because, just as a side note, this means two different things. If it's a subscript, it implies that it's bonded together. If it's a coefficient, it means that they are separate. And so what we need to do is to take it from a bonded fluorine to a separated fluorine. And we need to make it charged because it went from neutral to negative. So we have two things to accomplish for this fluorine. Again, it doesn't really matter which step you do first. I'm just going to save the charges for last. I usually save those for last. So we're going to turn this into two fluorine gases. These are separated. This is called the bond dissociation energy. Sometimes they just do BDE. So if you see that in a question, BDE stands for bond dissociation energy. Dissociate means to separate from. So if you dissociate from a club, that means you're no longer part of the club. So dissociate means to separate. So we went from a bonded fluorine to a separated fluorine. And now we have one more step. We need to take those two fluorine atoms and we need to add some electrons to them. It's going to take 2 electrons because we need each fluorine to receive an electron, and then we'll end up with 2 fluorine atoms that are negative and that are gases. And that is called electron affinity. However, electron affinity is only if you have one atom. So it's the energy that you get when you stick an electron onto an atom. And notice that we have 2 fluorine atoms and they each received an electron. So what we're going to have to do is multiply this amount by 2. So sometimes you have to do things to these numbers depending on how many you have. And that's pretty much it. And so now what we can do is to add all of these up to get the delta H. So in the question, they gave you numbers for each of these processes, the lattice energy, the sublimation, the ionization energy 1, ionization energy 2. And actually, when they give you all of that stuff, you can use that as a clue. So if they give you the bond dissociation energy, that means you're going to be breaking a bond. If they give you the electron affinity, that means you're going to be sticking an electron on. So you can use those to kind of guide you as you write these reactions out. To figure out how to get those, the final answer. And then, like I said, you just add up everything, including the lattice energy, and that will give you the delta H. So there's a few of these practice problems that I want you to try by yourself in the progress check. And then if you can't get the right answer, I'll go through and write out all these reactions for each of those during our live session.